Hi everybody, I'm Luigi Pastro from Variscite R&D team. Today we will talk about the LVGL graphical libraries in this webinar. That will be just the first part of the LVGL session. A new one will be in the next weeks. So, hi everybody, my name is Luigi Pastro. I'm part of the R&D software team. Today we will talk about the LVGL graphical libraries. This is the first part of the webinar. The next one will be in a few weeks. Today we will start with the LVGL basics. Let's see the agenda. We will have a very short introduction, then an LVGL introduction. We will see how to set up the host computer, how to set up Visual Studio Code. We will see a sample LVGL application. We will go through the basics of an LVGL application, and then we will go for the question session. Quickly, an introduction about Variscite. We are in this market since 20 years ago. We have an extensive customer base and pipeline. We have a stable supply chain due to the internal production facilities that ensure us to complete and control everything on the production and manufacturing. We provide direct support to the customers 24 hours a day because of the R&D team spread worldwide. Since a few years, we are an NXP Platinum partner, granting us to access early access to their hardware and DSPs. We provide the most diversified i.MX portfolio thanks to this partnership. We have a very high quality standard that can allow us to meet the strictly regulatory requirement, including the medical standard. And we have a wide ecosystem of partners that allow to provide a complete end-to-end solution. So the customization of the DSP, the design of the application, but even the hardware design if required. Which are the advantages to work with us? Basically, first of all, we do provide two pin-to-pin compatibility families, and that we will see later, that can grant the capability to scale up or down the SoMs that you are using on your own hardware. We allow a complete SoM customization in terms of components, in terms of sizes of the RAM, of the MC, whatever. All the time, 100% yield. Our hardware and software is production ready. We have thousands of customers worldwide that tested our DSP, and this through our high reliability with a low risk. We provide free customer support through the customer portal. All our code is public and provided through VariWiki, through the GitHub repositories. And we have also an extensive wiki, VariWiki, that is public and with no access restriction. And we also provide the complete CAD design file for the carrier board when you need to produce your own. All our SoMs rely on the longevity of the SoC from the manufacturer, that minimum starts from 15 years. For both hardware, obviously, and software, because we keep maintaining even older platforms. These are the two pin-to-pin family I was referring to. The first one is the SoM. It includes the very old SoM MX6, SoM Solo. It includes the SoM 6UL that are, let's say, the low end in terms of cost and capabilities. But it also includes the new entry from the 8M families, so 8X, 8 Max, 8M Mini, Nano, Plus, and the new entries that are the i.MX 93 and the AM62. All these SoMs share the same reference carrier, So you just need to unplug the SoM, plug the different SoM that you want to try, and use the reference SD card. That's it. So the design of the carrier has been optimized to work with all of these SoMs. Of course, some specific design constraints have been followed, but at least you have a single board that allows to test all these SoMs. On the other side, we have the Dart family with the 8M, the 8M Mini, and the 8M Plus that share the same board, DT8M custom board, where it applies the same logic. So you can change the SoM, you can change the SD card, and you can have the same the same carrier board useful to test these specific SoMs. Now let's move to the LVGL libraries, and let's start with a brief introduction. So in this workshop, we will show how to create a graphical application with a modern look and feel, and we will set up the development environment to create the application. We will set up a Visual Studio Code that is a very powerful system to debug and write your own code. We will create a simple application, very simple, and we will run it. Eventually, we will also debug it each time. This is the sample application that we will see, that you will see in the code, the ground, a label with a button, and whenever you will push the button, you will have a counter that will increase. Let's start talking about LVGL. LVGL is a free, completely free, open source graphic library. Please consider it's just a graphic library, nothing else. LVGL stands for Light and Versatile Graphics Library. It includes support for animation, visual effect, anti-aliasing, fonts, images, widgets. It's quite a comprehensive library from a graphical perspective. It's fully written in C, and originally was not designed for Linux, it was designed for microcontrollers. So the main driver behind this development was the very low footprint. Everything is configurable, so you can add or not add specific module, and you can slow down the application in a very powerful way. It's extremely modular, and as I said, it has been designed thinking to the small memory footprints, both in RAM and in the flash that you are going to use. Recently, this library has been ported to Linux, adding the FrameBuffer support, but also the DRM support. Here we will see the FrameBuffer implementation on top of the 6UL, that is the low entry SoM in our SoM family. What's included in LVGL? You have building blocks for creating interfaces like buttons, charts, lists. We will see in details later. It includes graphical features like animation, anti-aliasing, opacity, and also support the input devices. Specifically, it has some specific support for the Linux input devices. So you have them if you're familiar with this. But basically, you can include touchpads, mouse, and keyboards and encoder. A very powerful feature is that it's multi-language reading. So if you need to create your application for multiple platforms, multiple languages, you have already the infrastructure to prepare your application and the database of the strings that will be used for the different localizations. This library is fully free and open source, and it is distributed with the MIT license. So there's no constraint about the use of the code and the use in your own commercial application. As I said, it's light and versatile. All the elements are fully customizable. And there are different simulators you will find simulator for Windows, for Mac, for Linux, and that can run directly on a PC. And this is very useful when you need to design your own application. Whatever we did in this webinar and we prepared for this webinar has been done referencing the branch 8.3 of the LVGL. That is the latest stable. The application has been developed with the library version 8.3.9. So our goal are to set up the host system to develop a graphical application, run it on Variscite evaluation kit, understand the basics of LVGL. What we need the Yocto SDK with LVGL library enabled, the Visual Studio Code setup, and the Variscite AVK. Let's start with the host computer setup. First of all, you need to install Visual Studio Code. Be aware that what I'm saying is almost all present in the wiki with very little changes. Let's go for now through the instructions. So first of all, you need to install Visual Studio Code. You may have to download or build your own image using the Yocto SDK. In this case, we are referencing to the i.MX 6UL SDK. We are strictly referring to the FrameBuffer backend. Why FrameBuffer? Because it's the lightest one. Make no sense adding X11 or Wayland infrastructure when you are targeting a very low cost in terms of resources application. You will need to download or build the Variscite SDK. That will be a kind of shell script that will install all the required files. Just a few notes about the SDK. We used the latest Yocto Kirkstone SDK available for the i.MX 6UL. Here you can find the references. As I said before, we used the FrameBuffer backend because we don't really need neither X11 nor Wayland. We made very minor customization of the kernel that will not be present by default. I'm referring to the 16-bit per pixel that by default we have in our VSP. Being the 6UL targeting low resources application, to save memory, we use the FrameBuffer with 16-bit per pixel. Now, unfortunately, there is a LVGL limitation. There is a little bug when using this displays versions. So for this specific implementation, we switched the display of the 6UL to the 32 bits per pixel, because this is the one that is actually working LVGL side. About Variscite SDK, our layer, this is the layer where we have the, let's say, the user space customization. We introduced specific LVGL recipes, because if you look at the main line of the Yocto layers, you will surely find LVGL application, but they all mandatorily require Wayland. This is not a real request software side, because actually LVGL has been designed to work directly on the FrameBuffer. But this is how the community tested, and they were fine with this. Trying to limit the use of the resources, we introduced specific changes to the recipes in order to work directly on the FrameBuffer. By the way, these changes will be published in our meta layer, and we will also reference it in the video description that you will find in YouTube. Basically, you will find the reference for downloading a reference image, a pre-built image, I mean, with the FrameBuffer enabled with 32 bits. You will find the link for the SDK, pre-built SDK. You will find the patch for the kernel. It is a very dummy patch, nothing serious. And for the time being, you will also find the changes that we will be actually pushed to our own repositories for the time being, expecting the community to somehow integrate them. When you will install the SDK, basically you can download it, you can make it executable with the chmod command, and you can run. When it will be installed, you will see that it will create two different folders. One for the cross compiler, I mean the host machine, that is an x86 machine, and one for the target, that is an Arno machine. In these two roots, there will be the libraries compiled for these two targets. Let's talk about the Visual Studio customization. Visual Studio is extremely powerful. We recently, actually not that recently, but we moved to integrating Visual Studio in our wiki instruction some time ago, and we do provide some reference implementation. So we will go through this implementation, and we will explain the different settings. Basically, Visual Studio has a folder named .VSCode with some JSON file that are used to be to configure the environment. Then we will need the Makefile to compile the application and the script that will allow us to debug the application of the target remotely. Let's start with the C plus plus properties. Basically, this is just a list of include path. Be careful whenever you need to add a specific path, you may want to add the double star in the end, because this means that it will be included all the subfolders. Specifically for LVGL, to make the application work in the standard way, we also added the LVGL path, because some of the headers file directly refer to this path as, let's say, main path. So summarizing, the C++ properties is just for the include path. We have a launch JSON file that is used to explain how to launch the debugger. Basically, in our implementation, we have a custom script, but this is how the program will be launched and what is going to reference. And for example, here you can see that there are the reference to the target IP, that is the IP of the target port to be debugged, the port, I'm talking about the latest lines, and in the middle you can see the reference to the script that will be launched to enable the GDB. We have the settings. These settings report you the target IP of the board, the name of the program that you are going to compile. Basically, almost all of this is a cut and paste of what you can see in the wiki. But let me stress on the CC_flags. This is not in the wiki, and probably we will be added shortly. We observed the same in some corner case, a mismatch of behavior when using the Visual Studio Code and the native SDK in Yocto. This is because if you have the time to check how it works, basically whenever you install, it ends saying, okay, binaries has been installed, but you need to set up the environment running this script. The script that you are going to run in the specific case will set the additional flags for the compiler. These flags are here reported in the CEC_flags and align completely the Visual Studio Code behavior with the one of the native compiler. And actually, you can extract from the script, because these are just the additional flags that come in the script immediately after the reference to the compiler. This is the only notable thing on this slide. Finally, we have the tasks. Basically, we have the reference to the two tasks that we add, that are the compiling task, the one on the bottom, where we'll run the command, and the debug task that we'll call the var deploy GDB. These settings are integrated in the Visual Studio Code GUI, and this will allow you to run this specific task using these specific settings. What about the Makefile? The Makefile is actually a completely standard Makefile. What we did, maybe not so common, is to introduce a kind of shell script that finds all the C files to simplify. So this can be reusable basically with any project, because it will actually found by itself all the C files that will require to be built. Then there are the reference to the cross compiler, they include the sources that are from line 4, the linker libraries, and the program that was one of the variables that we set in one of the previous scripts. Okay. This is the deploy script. Basically, the script it's expecting the IP of the board, the program to be deployed, and it is in charge to connect to the remote carrier, kill the GDB server if running, then update, removing any program that was previously copied on the target, update the copy with a newer version, whatever it is, and then start again the debugger, the GDB server on the target. This will connect automatically with the GDB server Visual Studio side, and will allow us to have a complete control of the application while it is running. Now let's see a sample LVGL application, extremely sample. Here we are just aiming to understand the basics, so we will go deep in a more complicated application, say a complex application in the next webinar. But let's see the basics at least. We uploaded two demos. The current one is the LVGL demo 1, but you can also look for your own curiosity. Let's say the next one that we will be talking about in the next webinar. So the repository contains all the files needed for the project, including all the .VSCode files for the configuration. Keep in mind that if you follow the instruction by default, you will need at least to update the target IP, because it's just referring what we were using. We used the default installation path for the SDK, but if for any reason you need to change it, keep in mind that in the C++ properties file, you may need to update this wherever it is. Once you download this project and you open the project, in the wiki you can find also the reference to you can enter the folder and just run code dash full stop. That's it. Sorry, code space full stop. This will automatically load the project and you will be able to run the application. Now, your workspace will look more or less like this. So you will have the application, the source code of the application, and you will have the target, the terminal that, the terminal button where you will select the run task, and you can select also the build, as is explained in the wiki. But let's see now, also you can start debugging, going to run start debug. This is the standard graphical interface, so you can push on the buttons to start the application, place some breakpoint and whatever you need. Let's go through the basic structure of an LVGL application. So we said that this will be our application. There will be a background, there will be a button in the middle with a label on top of it that will be updated whenever you touch it. The basic structure of an LVGL application include some images that are always converted in a kind of C array, the inclusion of the LVGL basic files. There is the call to the LV-init, that is the initialization part of the library. You will need to initialize the display and the input device. You will have a section with the graphical interface according to your needs. And you will have a kind of event loop. Keep in mind that this was designed for microcontrollers that work in that way. So basically, there is a task that is refreshed, periodically called to update the graphics. This is the way it is also in this case. To convert the images, there is a free tool that is available from LVGL framework website, and you can just upload your image and convert it to whatever you need. Basically, we will be created a C file that you can include in the list of C files that you can include in your application. This is the main. So basically, as I was saying, you will find the initialization of the LVGL. You will see the initialization of the FrameBuffer, the initialization of the device, the input devices, and then you will have the sample graphical interface that is section 4, 5, and 6. But let's go into details. Section 4 is just the instantiation of an image. Basically, we are talking of the word background in this case. So if you remember, there was a background with an image that was just the base of the application. In the middle, there is a button. This button has a callback that is an event button handler. On top of this button, there is a label. We are in section 6 that is initialized with the string "click me please." Then there is the loop, event loop that I was talking about. Let's see in detail now the callback. The callback is just receiving an event. We filter the event to be sure that the event is the one that we want. In this case, it's the event clicked, raised whenever you click the touch, you touch the button, not when you say the touch. And what it's doing in this condition? It's updating the label on the button. That's how this callback works. There is the initialization of the FrameBuffer. The FrameBuffer basically has its own APIs from LVGL library. You don't need to care about the resolution. This API, the FBDev get sizes, just query the kernel and retrieve the information it needs. Then you initialize the descriptor of the of the buffer. Basically, LVGL never update the whole frame buffer, but just what is really needed. In order to achieve this, there are two buffers that can be used, a kind of double buffering approach that can be, usually the suggestion is to be somehow 1/10 of the full memory required for the frame buffer. So let me do it easy. If you have a square display 100 by about 100, you should have two frame buffer of 100 by 10. And here you need to to allocate 2 buffers for the size of 100 by 10 pixels. In case of 32 bits, we are talking about 4K, 4 kilobits. Once you initialize this frame buffer, these buffers, the last step is to initialize this display driver and register it, providing mainly the buffers, the callback for the update that is standard, and the resolution that you query to the kernel. Something similar happens for the input device. Our application allows to provide it as an input, but in any case, if you don't provide it, there will be a fallback. You set the frame buffer, you set the event device name, and you will initialize, setting it as the default pointer. This is about what we were saying, the input device in it. Okay, this closed the very preliminary introduction of LVGL. So if you like, we can go through the question, if any. We have a question about if LVGL uses CPU or GPU for 3D rendering. LVGL allows using 3D through specific API, but the 3D support comes from the microcontroller world for LVGL. For the Linux world, there is a kind of 3D support only when using SDL. But SDL is a graphical library, SDL, if you are aware of it, if you're not aware of it. But basically, SDL comes only for the Wayland backend. And we are back to the initial requirement of the community. Since the target here is for low entries and raw resources, we are focusing on the 6UL that does not provide the GPU. But still, you can build it using Wayland backend and through the SDL introduce the 3D support. We have another question about how disabling Wayland or X11 in a build. Let me clarify that for the 32-bit architecture that will not provide GPU support, I'm specifically talking about 6UL and 7. And for i.MX 93, that is a 64-bit platform which has no GPU. Basically, you can just use the FrameBuffer backend. If you go through the wiki, you will see that at some point during the build, you need to set up which is the backend. By default, the available backend are always X11, Wayland, and FrameBuffer. FrameBuffer is the basic direct access to the FrameBuffer of the device, and it's basically always available, but you have no acceleration on this. There's the Wayland backend that when the GPU provides Wayland library, it integrates the acceleration. And you have X11 backend that same as Wayland. When you have specific libraries that integrate the GPU acceleration with X11, will provide you dedicated acceleration. Keep in mind that the NXP relies on Vivante GPUs, and Vivante GPUs provide the acceleration only for Wayland backends. Okay, another question. Does the kernel patch also exist for i.MX SoM? I suppose was a mini or a nano, I don't know, but never mind. This patch that I was talking about in the beginning was specific for 6UL, and it's a patch that just changed the bits per pixel from 62 to 32. sorry, 16 to 32. This is why, by default, also for the 6UL actually is 32, but to save half of the memory in our implementation, we use the 16 bits instead of 32. So this patch is only required for LVGL when you use the 6UL. In any other case, it's not required. Let's see what else. There are questions about LVGL C++ code. Basically, all the LVGL code is in C. I suppose that can be ported also in C++, but the referencing implementation, the documentation always refer to C. Will the recording of this webinar be made available afterward? Absolutely yes. In a few days, if you go to the web page in our website where we list all the trainings, you will find a link to the video that can be used for viewing again it. Okay. We have another question. How flexible is LVGL in terms of customizing look and feel of graphical elements? We will see this in detail in the next webinar, but it's extremely customizable. The documentation is extremely wide. You can go through it even now. Just go through the link that I've shown you in the beginning. There is a dedicated, the documentation is auto-generated, and there is a specific section for the version 8.3 that is the latest stable. You will find several documentation about all the APIs, how to change, what to change. The capabilities are extremely wide, but also the community is very active. This is one of the reasons why we decided to go through this framework. Let's see other questions. Okay. We have a question about what the animation can do. Basically, they work on the base of the callback spirit. So you define an object, you define a callback for this object, and in the callback, you alter the object. When I say alter, I mean that you can change the position, you can rotate the object of a specific angle, whatever you like, according to your need. Is there an instruction for adding LVGL through Yocto? If you expect something from the community, unluckily not. What we did, we just investigated the code for Wayland. We added our own recipes, and these recipes will be public in our meta layer shortly, in a matter of days. But also through a specific link if you want to download just the changes in the video link that you will find in the website. Okay. Okay. What else? We have a question about the KMS backend. I must confess that we tested it because when we started the LVGL webinar, when we started the LVGL investigation, we originally started on the Mini because of some other conditions. And in the end, we decided to move to the 6UL. Whatever I proposed here was actually tested on the Mini before doing the 6UL. Just changing the reference to the build, because we built a mini image, and to the SDK, because we built an SDK for the Mini. But beyond this, all the rest is reusable, including there are no code changes, basically. On the Mini, differently from the 612, there is the support for the DRM and also for Wayland. That was part of the default implementation. We tested both the Wayland and the Mini, the DRM. Honestly, the Wayland was working fine. The DRM backend, apparently, it was slower than the FrameBuffer backend, but we did not investigate that much. Be aware that the porting to Linux of this library is quite recent. I'm not expecting it's that optimized like the one that is available from some microprocessors that have been driven in the past, the development of LVGL. Let's see for other questions. Does LVGL support single page application? If you mean single page, one page like the one that I've shown, yes. This demo, that is the one that you can download as LVGL demo 1, is just a single page with nothing else. The next one that you will see in the next webinar will be actually a kind of multi-page with some tabs and some nice effects that you may be interested in. Honestly, you can already see the code in the GitHub repository, so you can even try if you like it. We have a request about sharing the design. Basically, you will find the code in the repository, and in the code you will find the images that we started from as bitmap, and then the conversion that has been done using the tool that I've shown before. This will generate, you will find a file in the resource folder that is the translation of the bitmap in a C file. Will this work for i.MX 8? Formally, this will work for any CPU, because there are, if strictly talking about FrameBuffer, there are no constraints, but the requirement that the FrameBuffer must be 32 bits, just because of the limitation of the LVGL. That's it. This is the only requirement. Okay. Any other question? We have a question about the popularity of LVGL. I don't want to say too much about. I don't want to compare the different graphical interface. Let me tell you that LVGL is becoming very popular because of its look and feel mainly. If you go to the LVGL website, you can see the demos are very nice, and you can hardly understand that it's something that was designed for a microcontroller. It's really, really nice. I've seen very nice application for coffee machines, for smart kitchen, very, very smooth movement, even on a small controller, and it's amazing, believe me. Okay, there's one last question. How can I register for the next webinar? It will appear in the website in the same link that you find in our website. If you go to variscite.com and you go to services tab, you will find the Variscite training item, and here you will see that you can either register to the new ones or view the older one through YouTube. For the time being, I'm not seeing other questions, so let's say that let me thank you all for joining, and I hope to see you in the next webinar, probably mid-October. Thanks, everybody. See you.